just as in 2 dimensions where we had a Cartesian coordinate system and a polar coordinate system for things that were more circular, in 3 dimensions we have Cartesian coordinate systems, and also we have 2 other, instead of 1, we have 2 other coordinate systems, one cylindrical and spherical. Let's talk about the cylindrical coordinate system. So the cylindrical coordinate system makes it really easy to express things that look like cylinders or cones, things like that. It makes their expressions look a lot cleaner and nicer than the Cartesian coordinate system. So the idea is it's very similar to the polar coordinate system, except for that there's a z now. So we have our r, we have our theta, the exact same definitions as in the polar coordinate system, but now we also have this z going in the z direction. The good news is that the z, it just equals z. It's just like the z in our Cartesian coordinate system, so we don't have to worry about it. So in fact, it's identical. Everything is identical to the polar coordinate system. So we have our x, that's r cosine theta, and y is r sine theta, and theta is the tangent, the inverse tangent of y over x, and r is the square root of x squared plus y squared. So let's go ahead and do an example just to make sure that there are no kinks when we have a point in the Cartesian coordinate system when it converted to polar or cylindrical coordinate system. So, all right. So I have x by z, and what I'm interested in knowing is r theta z. So, well, the r is going to be x square root of x squared plus y squared, so 16 plus 16, right? Well, that's just square root of 32. The theta is going to be tan inverse of y over x, so tan inverse, I'm going to label these, tan inverse of 4 over 4. Well, that's just tan inverse of 1, which is just pi over 4, right? One of the answers to it, at least. So pi over 4. And then z is just z, which is 3. So in fact, our point in the cylindrical coordinate system is going to be root 32, pi over 4, and 3. And there you have it. That's a very easy example done in the cylindrical coordinate system.